Alright, so this is section 8.5, and those of you who haven't seen it, that's the Magic 5. It stands for the highest score that you can get on an AP exam, Advanced Placement Exams. And so we take a look at the Magic 5, get a little magic from it. There's one hanging in my door frame at school. So I thought I'd throw it out there for you, give everybody a chance to get some magic as you do these. Not that you need magic for these notes, but anyway. So we are continuing with proving triangles are similar. We've already done angle-angle similarity. So if two triangles have two angles that are congruent, then the triangles will be similar. So we're going to add two more to that today. We're going to do side-side-side similarity, which we indicate here. So this is similar to the congruent triangles, so hopefully you're kind of used to that. So if we have all three sides of one triangle proportional to all three sides of another triangle, then those two triangles are going to be similar by side-side-side similarity. And here, if we have two sides, two corresponding sides proportional, and the included angle, so that would be two sides and then this angle in between the two sides. So these two sides are proportional to two sides in another triangle, and the angle between them is congruent. And that's side angle side similarity. Okay, now in this proof, we're actually not proving triangles are similar. We're going to prove that triangles are congruent, but we're going to use similar triangles to get there. So hopefully you remember our congruence theorems. They are side-side-side congruence, side angle side, angle side angle, angle angle side, and hypotenuse leg. So those are back from chapter 3 or 4, I don't remember. Okay, so you can see I already started to highlight some things here. We are trying to prove that these two triangles are congruent. So I highlighted those in pink, and I highlighted those on the inside because I'm also going to have to highlight these triangles, and I'm going to highlight those on the outside. So triangle AEC, that's this triangle out here. So as I highlight that one, I'm going to highlight outside the lines. So a lot of times, like I already colored inside the lines here, so this time I'm going to color outside the lines so that that doesn't overlap. And here, outside also. So I stay in the frame there. So, alright. So there we go. Okay. So as we go through this proof, my daughter had my class last year, and she said, you know, the proofs. Some kids get a bad feeling about proofs, and it's if you practice and you memorize, they're very repetitive. We ask kind of the same things over and over again. So as we look at this. Let's just start with that. So they already have that marked on the picture. Segment DC is congruent to segment FH. So we'll start with that. And if you think about that for a moment, that doesn't really tell us anything else. So that's kind of a dead end. So it gives us a piece of information, but then we're done with that. So now let's move on to this green piece of information here. So that actually will lead us to some other things. So that is also given. Okay. Now what statement could that lead us to? What do we know about similar triangles? Well, we know the sides are proportional, and we know the angles are congruent. So we can get a couple of these angles congruent. So maybe angle A and angle G, and maybe down here angle C and angle H. And we could do E and F as well, but we only need 2. So how did I pick those 2? Alphabetically maybe, A and C. So angle A is congruent to angle G, and angle C is congruent to angle H. Okay, now that comes from this, and our reason should also come from that. So how did I know that those angles were congruent? Because we said that these were similar triangles, and so this is going to be the definition of similar triangles. That's how we knew that. Okay? Now we have we have a side in each pink triangle, and we have an angle in each pink triangle. So we need one more piece of information. And if we look here, these markings here indicate that these two sides are parallel. So what we can do is up here, we can get another angle to match up, because these two match up and these are parallel. So this angle is going to match up with that angle. So angle A is congruent to angle. Now here we have to be careful. We can't just say angle B, because there are 2 angles there at B, so we wouldn't know necessarily which one we're talking about. So we're going to have to use 3 letters to name this angle right here. So we're going to alphabetically, I'm going to say CBD. So angle CBD. Now, what was I talking about? I was talking about parallel lines, so we need to start with that. Parallel lines, and what do parallel lines tell us? Parallel lines tell us that these kinds of angles are congruent, and what kind of angles are those? Maybe you remember from last semester, that's going to be corresponding angles are congruent. Okay, so now we have those. So now, if you combine these 2 pieces of information, now we have G to A and A to CBD. So if we combine these 2 things here, now we can say, well, alphabetically I'm going to say this one first. So angle CBD is congruent to angle G. Getting rid of the middleman here, here to here, and here to here. These are the same, so we can bypass those and go directly to here. So that is the transitive property of angle congruence. And now if we look at these 2 pink triangles, we have an angle, and we have an angle, and we have a side right here. And the side is not in between the angles, it's outside of the angles. And so our reason for that is going to be angle, angle, side congruence. Alright. So now we move on to example 2 here, and it says which of these 3 triangles are similar. So let's kind of set this up and organize this somehow. So we have the small triangle, and then we have the medium triangle, and then we have the large triangle. And then across the top we have the small side, medium side, and the large side. So we fill in some of those things. The small side of the small triangle is 3, and the medium side of the small triangle is 5 and 7. So you, I hope, can pause and fill the rest of that out. And again, pausing on all these would be a good idea. So now we have 6, 15, and 18, And then the large one we have 10, 25, and 30. So we want to test a couple of these. So if we test, if we start from the small to the medium here, hopefully you can see that's going to be 1/2, and this is going to be 1/3. So those are not, so these are not similar. Okay? Now we can try these down here. Now if those were proportional, we still would have to check the third side, because we would need side, side, side. We need them all to be proportional. But we didn't have to check the third side because the first two weren't even proportional. So now we're going to compare these. That's 3/10. 3/10, and that's 5/25. That's 1/5, and that's not good either. So it's not the small and the medium, and it's not the small and the large. So if anything's going to work here, it's got to be the medium to large. So if we try that out, I'm running out of room for that. Let's see here. So 6, I should have reduced it. So 6/10 is 3/5. And what about here? We have 15/25. And 5 goes into there 3/5. And the last one here, 18, divide that by 6, you get 3. Divide that by 6, you get 5. So I guess I'll write that out. So that's 3/5. So they're all 3/5. So we're going to say that triangle, and alphabetically here we'll go K, where we at these two, KLM. KLM is similar to triangle, and K is in between the short and the long. So the short and the long here, that's Q. So, and then L was between the long and the medium, so that's R, and S. And our reason for that is side, side, side similarity, because those sides are all proportional. Okay, last one on this page. Let's see here. AC is 6, that's already labeled for us. AD is 10. So if AD is 10, we can do a little more highlighting here if we want to. AD is 10. So that means that 10 minus 6 would be 4. So we know that's 4. And let's see here. BE is 15. So this side is 15. So 15 minus 9, that's going to be 6. Okay. So 15 minus 9 is 6. And here we had 10 minus 6. 10 minus 6, that's 4. Just showing where we got some stuff there. Okay, so describe how to prove that this triangle is similar to this triangle. Well, let's just start right here. We have these angles here. So we have vertical angles, and so we can say vertical angles are congruent. So we have those angles. Now, if we test these sides, so we're looking at, what do we want to do here? Let's do the small over the large. So CD needs to go with AC. So CD is 4, AC is 6. So that's going to be 4/6. And then what do we have over here? We have EC and CB. So we have these two. So we went from the small to the big, so we need to do that here as well. So that's going to be 6/9. So this reduces to 2/3, and this reduces to 2/3. So those are equal, proportional. Okay. So those are proportional. So now we have an angle in between proportional sides. So that's going to be side angle side similarity. It's kind of important to put similarity because we also have side angle side congruence. Okay. Alright, so you may want to pause this and highlight the triangles like I did there to help keep that clear. So how do we know that these two triangles are similar, the pink one and the green one? Again, notice how that's on the outside and this on the inside so that the colors don't overlap. And so we already have up here that PB over PD is equal to PA over PC. So that shows that this side of the green triangle over this side of the pink triangle is equal to those, which means they're proportional. Okay, now here the pink and the green triangle share this angle. So angle P is congruent to angle P, and hopefully some of you remember that when we say something's congruent to itself. That is the, if we were on class, a bunch of you would say that out loud, the reflexive property of angle congruence. Okay, and so now we have the proportional sides on each side, and we have the angle in between. So the reason that we can say those two triangles are similar is because of side angle side similarity. Now, if we fill in these things, PA is 8, and AC is 8. Diameter of the daisy. Okay, yeah, this isn't that important. A pantograph was is this just thing that would help you trace this. So that's not important. It's just making an enlargement. So the daisy is here, is the flower, and we're making a larger picture of it. So the diameter of the daisy is 1.8 here. Okay, and they're asking us what's the diameter of the enlargement. So remember, when we're trying to set up a proportion like this, what we're trying to find, we want to put in the numerator of the first fraction. That'll be one of our extremes. So d over 1.8 is going to equal, so that's the large triangle compared to the small triangle. So the trick here that messes some students up is the large triangle here is actually 16. So this is going to be 16, and the small triangle is 8. So this reduces to 2 over 1. You could cross multiply 1 times that. It's not a big deal. But if that was not a 1, I would not want to cross multiply. I would just want to multiply both sides by 1.8. That would be my suggestion there. So if we multiply both sides by 1.8, this cancels, and we get that the diameter is equal to, that's 3.6, and that's going to be inches. Okay. Alright, so here we have a person, and they're looking down at a mirror, and the mirror is pointed to the top of a wall. That's a pretty tall wall. The person is standing 5 feet away from the mirror and 60 feet away from the wall. So you would assume that the person would be perpendicular to the ground and the wall will be perpendicular to the ground. Also, by looking at the mirror and that reflection going directly up to the top there, that these two angles will be congruent also. So by angle-angle similarity, these two triangles are similar. So remember, this is similar. We've had several of these questions throughout Chapter 8. We're trying to find the height of the wall, so I'm going to use W for the height of the wall, and we always suggest that you start with what you're trying to find in the first spot of the proportion, the extreme. These are the extremes, these are the means. And now we just need to match that up. So we could do the wall over 60. And if we do the wall over 60, then this needs to match up, so that would be 6 over 5. Okay, now some people talk about cross multiplying right here, but if we just multiply both sides by 60, then this side is done. Now here, you can reduce before you multiply, so 5 goes into 60 12 times. You can double check that, multiply 50 plus 10 is 60. And then 6 times 12 is 72. So that's going to be 72 feet. Here we're going to have a very similar situation. So we have these two triangles, and if this is a river and we're looking across the river, maybe there's a tree here and a rock here, or something. You measure the distance between there. And so here you have vertical angles, so those two angles are congruent because all vertical angles are congruent. Here we have two right angles, and all right angles are congruent. So again, we have angle, angle. And so these were ways that people could find the measures of things using similar triangles in the past. And I mean, we can still use it today, but we have other tools that we can use as well. Use given links to find the width of the river, LM, so I'm going to call that R for the width of the river. So again, we start with that first, and I'm going to take the river compared to 42, and then this side would match up with that side, so that's 5, so 5 goes with, so R over 48 and 5 over 8. Okay. So if we multiply both sides by 42, we can reduce here, so we definitely can divide by 2. So that looks like about it. So that's going to be 105 over 4, which is a little bit awkward for length. It's a word problem that's asking us for the width of the river. These are all in feet. So if we divide that, that's going to be 624. And then that's our remainder, but we would want to write that as a mixed. So that's going to be 26 1/4 feet. Now, if it's just a normal fraction problem with no words associated with it, we usually will let you leave it like that. Those are equivalent, but in a word problem, usually it makes more sense to write it that way. Alright, so that wraps up the new material. Now we're going to do a little bit of review. So again, we're really focusing on factoring because you're going to need factoring a lot in Algebra 2 Honors. So two of the things we want to consider are GCS and can we factor again. So again, this would be a good place to pause. We've been working on factoring, so hopefully you could factor these yourself and then check your work, although possibly this might be a new twist. So, GCF 3, all those can be divided by 3. Oops, I didn't divide by 3 there, did I? So that should be 7. And then dividing that by 3. There we go. So students lose track of that 3, so I like to suggest you put it down in the answer line right away. So there's 3. And then we're also going to have some x's and y's in here. Like this. Okay. So if we look, we have a positive 10 here, so that means that the signs have to be the same. And then, so number 1, same sign, and then here, number 2, they both need to be negative. So this needs to be negative, and this needs to be negative. And then finally, we want two things that multiply to give 10, but add up to 7. So if you need to, you could list them all, but I'm sure that we all spotted 2 and 5 pretty quickly there. And so it's going to be 2 and 5, or 5 and 2, it doesn't matter. So there we go. That's it. Now if we move over to this one, there seems to be a lot going on here. So I'm going to start with the coefficients. So those all can be divided by 3. We're going to check A's. There's no A down here, so we can't factor out an A. We have a B squared in all three of them, so we can factor out B squared, and they all have a C in them also, so we can factor out the C. So all of this factored out except A squared. 24 divided by 3 is 8, and that's an A left over there, and then that's 15, and both of those factored out. Okay. So this one, when A equals 1, just like it did here, the thing, well, I said A, that's usually we use the coefficient of the squared term as A, but this is A, so that's a little confusing. So normally, when that is just being multiplied by 1, it's pretty easy to factor stuff. We don't have to use any of the techniques for more complicated situations. So here, this is positive again, so they're both the same, and then this is negative, so they're both negative. And we need factors of 15 that add together to give 8. So there are only the two pairs, and pretty clearly it needs to be 3 and 5, so, or 5 and 3, either way. And that's it. And we can talk about factoring again, but it doesn't really, we just check to see if it factors again. Okay, now this is quadratic form. So when you have this in the middle and you square it, well, it doesn't have to be in the middle, they could rearrange it to try to make it more confusing, but I haven't seen them do that really. So if we take this and square it, then what that means is this acts the same way as a quadratic. So if we switch that to x squared and this to x and we compare them, you don't have to switch it, but we're going to do it in the notes this one time. So then this should factor the same way this does, because x squared is x squared, just like p squared squared is p to the fourth. So if you think about how this factors, they're both positives, so that means that these are both going to be positive. And then factors of 5, well, there are only two factors of 5, that's 1 and 5. So that's how that factors. Now, if we go back, we say, well, wait, we didn't have an x, we had p squared. Well, if you look at it, so this x goes right here and here. So following that same pattern, it would be p squared, and then those would be the same, so that, and this would be p squared plus 5. So it's just a matter of recognizing that. Now if you recognize it, you can go directly to here. You don't have to write this down. That was just to try to compare them. Let you see that. So b cubed squared is b to the 6th. Okay, so what that means is this will be b cubed and b cubed, like that. Now this is negative, that means these need to be the opposite sign, so one of them is positive and one of them is negative. So now we need the factors of 14 that subtract to give 5. Again, not that many to look at here, just these, and we can see that if we subtract 7 minus 2 we'll get 5. So we want the 7 to be positive and the 2 to be negative. That way we'll get 7b cubed minus 2b cubed, and that'll be 5b cubed. Alright, so let's wrap this up with a couple more math competition questions. Let's try to do this fairly quickly. So there were 5 people in a room and their average was 30. So if you think about it, average age, let's use A for the ages. That's the sum of the ages, and there were 5 people. So if we took the sum and we divided it by 5, we had 30. Okay? So if we multiply both sides by 5, we find out that their ages added up to 150, the people in the room. Okay? Really, these are math competition questions. It would be nice if you'd pause it and think about it. I didn't really, that's just something that always should be in your mind about pausing them. So we had 150 total years in the room if we added up everybody's ages. Then an 18-year-old left. So now that's going to be the new sum. And we had 5 people, but the 18-year-old left. One person left. So the question is, what's that new average now that that person's gone? So you got to be careful because you're going to have to borrow here. Or you could think about, this is 2 less than 20. So if we subtracted 20, we'd get 130. But we're not subtracting 20. We're only subtracting 18. So we got to add 2 back on. Or you could just stack it over here and borrow. And then you should get 132. And 132 divided by 4. Now, if you think about it, what should happen to the average age? A younger person left, someone younger than the average. So now the average age should go up. So let's see if that happens. So this is going to be 312, and that's what happened. So 333. So just from that fact alone, we could have eliminated these 3 questions. Because since someone under 30 left, the average age should go up. So those 3. So knowing little tricks like that should really help you on multiple choice math tests. Okay, so we have a trapezoid. So by looking at this trapezoid, that tells us, remember, trapezoid has 1 pair of parallel bases. So the top and the bottom are going to be parallel. It says that AD is perpendicular to DC. They already have that marked. AD is 3. AB is 3. Those are both marked. DC is 6. All the way across here is 6. E is on. Okay. BE is parallel to AD. So these are also parallel. I told us that right there. Find the area of the trapezoid. So the area of a trapezoid is the average of the bases, which we can find by taking 1/2 base 1 plus base 2. Times the, wait a second, find the area of triangle BEC. Okay, so I wasn't totally paying attention here. I was about to find the area of the whole trapezoid there. So let's pause for a second and focus on that triangle. So you don't need to write this down. You could erase this if you want to. This would be the trapezoid, but we don't need that right now. So, alright, so back to this. We're trying to find this triangle. So the key here is that this is a parallelogram because it has 2 pairs of parallel sides. So once we know that, then we know that consecutive angles are supplementary, so those would both have to be 180, and these also both would have to be 180, and at that point it turns into a square. So this is 3, and this is 3 also, based on that. Okay, so we have a parallelogram and a right angle, so that leads us to having a square, and all 4 sides are equal. So this whole thing was 6, so 6 minus 3 is 3. And now we're pretty much done. The area of a triangle, one area of a triangle formula is 1/2 the base times the height. So that's going to be 3 times 3. Since these are both odd, I would multiply those together first, and I would get 1/2 of 9, which would be 4.5 units. We don't know what the units are, squared, and that was choice B. Okay, it's about that time. Have a good day.